This lecture is for Chemistry in the Earth System, continuing Unit 1.2, Thermochemistry. Today's essential question: how do you distinguish between exothermic and endothermic reactions and processes? How do you distinguish between exothermic and endothermic reactions and processes? Our first main idea: releasing energy. Releasing energy. As wood burns, energy is released. Combustion of the wood releases energy in the form of light and thermal energy. Likewise, the synthesis reaction of sodium metal with chlorine gas, for example, also releases energy. Chemical reactions that release energy are called exothermic reactions. Exothermic reactions. The combustion reaction, such as that of methane with oxygen or propane with oxygen, is another exothermic reaction. During each reaction, energy is released as light and thermal energy. Where does this energy come from? The energy released during a reaction results from a decrease in the chemical potential energy as reactants change into products. Chemical bonds between atoms store chemical potential energy. In an exothermic reaction, the products of the reaction have less chemical potential energy than the reactants. The difference in potential energy is released as light or thermal energy. Our next main idea: absorbing energy. Absorbing energy. Some chemical reactions and physical processes release energy. Others absorb energy. Energy is absorbed during an endothermic reaction or process. Toasting marshmallows and popping corn are endothermic processes. The substances absorb energy as they undergo changes. Boiling water and melting steel are also endothermic. The water or steel must absorb energy to undergo the change. Instant cold packs work on the basis of an endothermic reaction when a solid is dissolved in water. Energy is absorbed by reactants during this reaction, so the pack becomes cold to the touch. Another example of an endothermic process is photosynthesis. Energy is added to the system from sunlight and helps the plant convert carbon dioxide and water into glucose and oxygen. The energy absorbed remains in the glucose molecules. The decomposition of sodium chloride into sodium and chloride is the reverse reaction of the exothermic process described previously. Energy must be absorbed to break the chemical bond between sodium and chlorine. The potential energy stored in the bond is greater than the chemical potential energy of the products, which are sodium and chlorine. The reactant must absorb the difference in energy to undergo the reaction. At this point, you should be able to construct a full and complete response to today's essential question: how do you distinguish between exothermic and endothermic reactions and processes?